Okay, so today we are going to be looking at how to solve greatest common factor. As a little warm-up, I'd like you to pause the video and try all 5 of these on your own, just finding the prime factorization for each one. Okay, so for 20, it ends up being 2 times 2 times 5. For 100, it ends up being 2 times 2 times 5 times 5. This would also be 2 to the second power times 5 if you wrote it with exponents. This would be 2 to the second power times 5 to the second power. 30 would be 2 times 3 times 5. 128 ends up being 2 times 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 7th. And 70 ends up being 2 times 5 times 7. Now what we were doing with prime factorization is going to lead right into what one of the methods that we're using today, which all of it is going to find the greatest common factor of 2 or more whole numbers. So first, let's take a look and define what a greatest common factor actually is. So we've been working a lot with factors when we've been doing our factor trees and our prime factorization. So the greatest common factor of 2 or more whole numbers is the largest whole number that divides evenly into each number. Okay, so we're always talking about division when we're looking at greatest common factor. We're taking numbers out and dividing them out. One way to find the GCF of 2 or more numbers is to list all the factors of each number. And then the GCF is the greatest factor that appears in all the factors, or in all the numbers. So let's look at an example of what this would look like. This first method that we're going to try is what's called the rainbow method. So you're simply going to make a list of all possible factors for each number. For example, 12 can be found by taking 1 times 12. You can also get it by taking 2 times 6 or 3 times 4. Now when you're in the middle and the numbers meet, you know that you're done with your factors. It's called the rainbow method because a lot of times you'll see people draw lines between the factors that create the number, kind of creating that rainbow effect. So for 36, same type of thing. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then the last one would just be 6. $54 would be 1 and 54. 2 and 27. 3 and 18. And then you have 6 and 9. So here we would list all the factors for each number, and then we're going to circle the greatest or the largest factor that is in all the lists. So when we sit here, we could sit there, okay, they share a 2, they share a 3, they share a 6. Nothing else is in common for all 3, so their GCF would be 6. Alright, so now it's your turn. You're going to try the same method for all three numbers. I want you to list out each of the factors, circle them all, and then find the one that is the biggest. So go ahead and pause the video and try this out on your own. Alright, so for 14, when we start with that, we have 1 and 14, and then 2 and 7. If you want to draw the rainbows, you can. You don't have to. For 28, we have 1 and 28, 2 and 14, and then 4 and 7. For 63, we would have 1 and 63, 3 and 21, and then we would also have 7 and 9. If you go through and circle your common factors, they have 1, they all have 7, and then that's it for their common factor that they have. So 7 would be their greatest common factor. Now, I will be honest, I personally do not like this method. I think it's very time consuming and it's difficult because if you had a big number to try and list out all the factors, it could be very time consuming. And then it's very easy to miss factors in between as you're going. But it is a method that you can use, so just keep that in mind. Now, there is a second method that we can use, and this ties in that prime factorization or those factor trees that we've been using. So, first thing we're going to do is you're going to factor each number. Okay. Now, you can go ahead and do your factor tree if you want. So 40 would be 8 times 5. 8 would be 2 times 4. 4 would be 2 times 2. Now, for sake of space, I'm not going to factor out 56 completely. I'm just going to go ahead and put the prime factorization for it. So 40 is going to be 2 times 2 times 2 times 5. And then 56 is going to be 2 times 2 times 2 times 7. Now, just like we did before, you're going to circle all common factors. So in this case, they share a 2, they share a 2, and they share a 2. Then you're going to write out the common factor. So in this case, we have the GCF, we have 2, 2, and 2. So notice, each one of these pairs, I'm only writing 1, 2 for each of the pairs. And then you're going to multiply. And that is going to give you your GCF. So here we have 2 times 2 times 2, or 8. So our GCF for 40 and 56 would be 8. Now it's going to work in a very similar fashion when we are doing it with three numbers. So we're going to go ahead and write out the prime factorization for each. So we have 96, 180, and 252. I would encourage you to go ahead and pause the video and just try this one out on your own to see how you do. So here, 96, if you want to write out your factor tree, would be 2 times 48, 2 times 24, 2 times 12, 2 times 6, and then 2 times 3. So it ends up being 2 to the 5th times 3. Now notice, I'm actually going to write each of these out. I think it's easier when you do this for circling the common factors. So we have 2 to the 5th times 3. 180, I'm just going to go ahead and switch colors. So we have 10 times 18, which would be 2 and 5. This would be 3 and 6. So this would be 2 and 3. So this ends up being 2 times 2 times 3 times 3 times 5. And then for 252, we have at least 2 and 126. 126 is even, so I can divide that by 2 again. Should be 2 and 63. 63 is not even, but it is divisible by 6 and 9. Or no, I mean 7 and 9. And then 9 would be 3 and 3. Okay, so we have 2 times 2 times 3 times 3 times 7. Now we're just going to go ahead and circle anything that they have in common, but it has to be in common for all three. So here's a set, here's a set, and then they also have a set here. Now you will notice that, for example, 180 and 252 share another 3. However, because it's not shared among all three, we can't circle it. So we're only circling what's in common for all three. Now we're going to write it out. So your GCF is going to equal 2 times 2 times 3, or remember 1 for each set that we've circled. 2 times 2 is 4, times 3 is 12. So that's the first two methods. I think prime factorization works well, but once again can be kind of time consuming because you have to break it down to its prime factors. So there's one more method I'm going to introduce you to. This one's probably brand new. Most people haven't seen it, and it's what I like to call the cake method. And who doesn't like cake? So obviously it's got to be a better choice because cake is delicious. Alright, so what this is going to do is we're going to take our two numbers, and the reason I like this method is because for this, you can pull out any factors that you notice that you like. So it's not a matter of just pulling out the prime factors, it's just any factors that you see. So here we have 72 and 84. I'm going to draw what I consider a layer, because we're going to make a layer cake, underneath, and you're going to pull out a factor. So what's something that 72 and 84 can both be divided by? Well, they're both even, so I know at least I could divide out a 2. So then what I'm going to do is I'm going to say 72 divided by 2, and that's going to be 36. So underneath the 72, I'm just going to go ahead and put 36. Now I'm going to do the same thing. 84 divided by 2 is going to give me 42. Alright, I'm going to draw another layer because 36 and 42 are even again. So I'm going to go ahead and pull out another 2. Or actually, let's just say here, I didn't want to pull out a 2 and I noticed, oh hey, I know that 36 and 42 are both divisible by 6. So I'm going to pull out a 6. Either way, it doesn't matter. It just depends on, just like with prime factorization, sometimes you might be able to pull out bigger numbers sooner. Sometimes you might just be pulling out 2. It depends on what you see. So 36 divided by 6 is 6. 42 divided by 6 is 7. Now at this point, I don't need to draw another layer because when I look at 6 and 7, even though 6 is composite and can be divided into 2 and 3, 7 is prime and doesn't share a factor with 6. So we're done at this point and we're going to stop. So now for the GCF, we're just going to look along the side. We're going to circle those common factors. So here they shared a 2 and they shared a 6. So just like before, I'm going to multiply 2 times 6 and I get 12. So the greatest common factor of 72 and 84 is 12. Now just to show you that it would have been the same, you just kept pulling out 2's. So if we did 2, this would be 36 and 42. So if I pulled out a 2 again, it would be 18 and 21. But now here, we could pull out a 3, and then it would be 6 and 7. So notice we still end up with the same numbers on the bottom. We maybe ended up with more numbers over here, but now it would be 2 times 2, which would be 4, times 3, and you would still get 12. So if you notice, same thing, doesn't matter. Still get the same answer as long as you pull out your factors until you can't pull them out anymore. So at this point, pause the video and I want you to try 170 and 40 all on your own. Do the best you can, pull out any common factors, and at least get as far as you can and then check your work. So I have 170 and 40. I'm going to go ahead and draw my layer. Now for me, I notice they both end in 0. Well, whenever I see a 0, I think, oh, I can divide by 10. So I'm going to go ahead and pull a 10 out right away. You might not have, and that's okay. This is just what I'm doing. You can always just check your work at the end. So now here, 170 divided by 10 gives me just 17. 40 divided by 10 just gives me 4. Now if you notice on these two, I got to continue on. On this one, I'm actually going to stop because 17 is prime and it doesn't share a factor with 4. So here, this one's so easy in the fact that we don't even have to multiply anything. It's just simply that number. The GCF would be 10. Okay, so now we're going to take a look at a word problem situation where we might use greatest common factor to solve it. So we have 120 red beads, 100 white beads, and 45 blue beads. We want to use all the beads, so we're going to use them all to make bracelets that have red, white, and blue beads on each. We want to know what is the greatest number of matching bracelets that you can make. So whenever I'm reading these word problems, I like to look for keywords like greatest because that's usually going to indicate that I'm trying to find the greatest common factor. In this situation, we want to have no leftover beads, so we want to split out the beads so that each bracelet has the same number of red beads, each one has the same number of white, and each has the same number of blue. But we want to make the greatest number of bracelets possible. So I'm going to go ahead and use the cake method, just because I think cake is delicious. Alright, so here, 0, 0, and 5, so I know that they can all be divided by 5. 120 divided by 5 is going to be 24. 100 divided by 5 is 20. And 45 divided by 5 is 9. Now at this point, I can actually go ahead and stop because 24, 20, and 9 don't all share a common factor, so 5 would be the greatest number of bracelets. So now it's your turn. Go ahead and pause the video, read through this problem, see how you do, and then check your work. Alright, so Nathan has made fishing flies that he plans to give away as gift sets. He has 45 wet flies and 18 dry flies. And we want to figure out how many sets. So we're splitting them up into smaller groups or dividing, so that's why we're looking for factors. Once again, I'm going to use the cake method. You could use prime factorization, you could also use the rainbow method. 24 and 18. I know I at least can take out a 3. This would become 8, this would become 6. 8 and 6 are both even, so I know I can pull out a 2, which becomes 4 and 3. 4 and 3 are relatively prime, they don't share any common factors. So this would become 2 times 3, which would be 6, would be the greatest number of sets he could make. Okay, so now it's a little self-check quiz. I think it's best if you pause the video, work through both pages of this quiz, and then check out your answers and just see how you do, and then you can go ahead and get started on tonight's homework. So for 28 and 40, their greatest common factor is going to be just 4. For 24 and 56, it's going to be 8. For 54 and 99, it's going to be 9. For 20, 35, and 70, it's going to be 5. Okay, and then on this last problem, once again a word problem. So if we look here, greatest number of members that could be on each team, if we have 16, 24, and 72. So, using the cake method, I have 16, 24, 72. Each can be divided by 2, so then this would be 8, 12, and 36. Can all be divided by 2. 4, 6, 18. They can be divided by 2, which equals 2, 3, and 9. GCF is going to be what's on the side because I can't go any further. It's going to be 2 times 2 times 2, or 8. 8 would be the greatest number of members. So like I said, at this point, you're done with the video, go ahead and start on tonight's homework.